Hello everyone. I welcome you all to the Internship Studio session on AWS EC2, which is short form for Elastic Compute Cloud. So we'll be discussing about the introduction, the different types of offerings which the AWS has provided with respect to EC2. We'll also discuss about the best practices that we need to use for operating on EC2, and we'll also do the hands-on demo of the creation of EC2 instances and the different ways of connecting to it. So I once again welcome you to this session. So jumping directly into the introduction. So before we go deep into what EC2 is, we first needs to understand the concept behind the setup of EC2. So we need to first ask the question, what is a virtual machine in the cloud? So we have a definition. A virtual machine in the context of cloud computing, it refers to a software emulation of a physical computer or a server that runs on an operating system and applications. Virtual machines are created by virtualization technology, allowing multiple VMs to run on a single physical server or host. So this technology decouples the software from the underlying hardware, providing flexibility, scalability, and resource efficiency. So I understand that this is too much of the technical details that is given in this definition. So we'll understand by emulating a scenario. So I'll give you simple examples. Uh, to make this more simpler, so you can imagine a virtual machine. It is like a computer within a computer. It is actually a software-based simulation of a physical computer that can run its own operating system and applications. So most of you are familiar with Windows operating system, right? So which is the OS for professional computers manufactured by Microsoft. So you can imagine your computer running Windows but with a virtual machine. So you can also alongside it run another operating system like Linux. So Linux is mostly a command line based operating system which is not having a graphical user interface like Windows. So you can run the operating system of Linux along with the Windows as if it's a separate computer, all within the same physical machine. Uh, there's a core component at the core of virtualization. So there's a piece of software called a hypervisor. So in the backend coordinating all these operations, we have this hypervisor which acts like a manager, which is overseeing and coordinating multiple virtual machines on a single physical host. So it allocates resources such as CPU, memory, and storage to each virtual machine, ensuring that they operate independently. So one practical example of virtualization is server consolidation. So in a traditional setup that we used to have before, each server usually ran on a single operating system and an application. But one drawback was that would lead to very underutilized resources, as one server might not use all its processing power or memory. So what virtualization made is it allowed multiple servers to run on a single physical server. So this consolidation, it actually helped, where it helped us to optimize hardware use, reduce costs, and make data centers more efficient. So these virtual machines are also invaluable for software development and testing. So developers can create virtual machines with different operating systems to test their applications on various platforms without needing separate physical computers for each one. So what this flexibility offers is it accelerates development cycles, and it also ensures software compatibility across diverse environments. Moreover, what these VMs help us is they also enhance system security and isolation. So each virtual machine operates independently. So if one VM encounters a problem or gets infected with malware, it doesn't affect the others or the host system. So this isolation is crucial for maintaining a very stable and secure computing environment. So all in all, in cloud computing, VMs play a very central role. So actually all the cloud providers that we have, for example, taking the examples of major ones, we have AWS, we have Microsoft Azure and Google Cloud. So they use virtualization to offer scalable and flexible services to users. Actually, when you deploy a virtual machine in the cloud, for example, in terms of AWS, we call it as a EC2. You're essentially running a simulated computer on a physical machine owned by the cloud provider, in our case, who is AWS. So, what this allows businesses to scale their computing resources up or down based on demand without the need to invest in and maintain physical hardware. So, overall, virtual machines bring efficiency, flexibility, and cost savings to computing. So, the virtual machines also enable the coexistence of multiple operating systems on a single machine. So making it very easier to manage resources, test applications and enhance security. So whether it's server consolidation in data centers or providing on-demand computing in the cloud. So virtual machines have become a fundamental block of modern computing infrastructure. So hope you understood and had an overview of virtual machine in the cloud. So we'll understand the architecture of a virtual machine. So we can see at the base of the diagram we have this physical hardware which is common. We have the host operating system. We have the VMware hypervisor, and we have these VMs which is hosted on top of them, virtually VM1 and VMN. So we can host n number of virtual machines. So it has their own application. It has the guest operating system, which is the custom operating system of that respective virtual machine. Actually, as we know already, a virtual machine operates with a structure that involves key components working together to simulate the functions of a physical computer. So let's delve into the architecture. So the number one is the host machine. So we can see this whole three components that we have. So this comprises of the host machine infrastructure. So at the foundation of a VM is the host machine, which is your actual physical computer. So this machine has its own operating system, which is the host operating system. So it can be either Windows or Mac OS based on the configuration that we have. So the host machine, it is responsible for running the hypervisor. So for example, in our case, we have this VMware hypervisor. So VMware is a popular enterprise company which is offering this hypervisor software. So what this hypervisor is, so it is a critical software that manages and facilitates the creation and operation of virtual machines. So coming to the hypervisor, so the hypervisor it is also known as a virtual machine monitor in simple terms. So actually it is the brains behind the virtual operation. So it is the main brain, you can say. So it is the mastermind behind this virtualization operation that is taking place. So it sits between the hardware and the operating systems, as we can see. It is sitting behind the physical hardware of the host machine and between the operating system of the host machine. It oversees the allocation of resources, and it also ensures that each virtual machine operates independently. So typically there are two types of hypervisors. There is type 1, which is also known as bare metal hypervisors, which runs directly on the hardware without the need for a host OS, while type 2 hosted hypervisors run on top of an existing operating system. So we also have another inbuilt component, which is a virtual machine manager, which is called in short as VMM. So the virtual machine manager is a component of the hypervisor which is responsible for creating, configuring and managing the virtual machines. So what it does is it interacts with the host machine's OS and the hardware, ensuring that each VM gets the necessary resources like CPU, memory and storage. The VMM also handles the communication between virtual machines and coordinates their activities. Also we have the guest operating system, which you can see in the blue section. So it is part of the hosted virtual machines which are hosted on the already existing virtual machine, a physical machine you can say. So within each virtual machine that we have, there resides a guest operating system. So this is the operating system that you install and run inside the virtual environment. So it could be Windows, Linux or any other OS compatible with the virtualization platform. So each VM operates as if it's an independent computer with its own OS. So VM1 is a different computer altogether. We could be having VM2 somewhere here, or VMN. For we can have a similar n number of computers sitting beside on top of this single physical computer. All the applications, the OS and the user environment is segregated logically. We also have other components. We are having the virtual hardware. So the virtual hardware represents the simulated components within each VM. This may include the virtual CPU, the virtual memory or RAM, the storage and network interfaces. So what this VMware hypervisor does is, in our case, it allocates a portion of the host machine. So whatever this host machine is having, the resources, for example, it may be having 10 GB or 12 GB of RAM and 4 virtual CPUs and a hard drive. So what it does is it will distribute and allocate a portion of this host machine's physical resources to each VM, VM1, VM2, VM3 accordingly. For example, you can configure this VM with 2 virtual CPUs or 4 GB of virtual RAM and a virtual hard drive from the existing configuration. So this also built-in emulation layer within here to make the virtualization magic happen. So there's some emulation layer here. So that translates the requests and instructions from the virtual hardware to the actual hardware of the host machine. So this ensures that the guest operating system and applications running within the virtual machine can interact seamlessly with the physical hardware even though they are operating in a virtualized environment. So at last we have this application layer. So on top of the guest operating system that we see here, you have the applications and services that users interact with. So these could be anything from word processors and web browsers to server applications and databases. So users can interact with the applications just as they would on a physical machine. But the underlying operations are managed by the virtualization infrastructure. So in summary, we can see the architecture of a virtual machine involves the host machine, which runs the hypervisor, overseeing the multiple virtual machines. So each virtual machine consists of a guest operating system, virtual hardware, an emulation layer, and application layer. So what this setup does is it allows for an efficient and isolated operation of multiple independent computing environments on a single physical machine. So this is about the architecture of a virtual machine. So coming to the history of virtualization. So it's very important that before jumping into the advanced concepts, it is always a good thing to know about how the technology evolved. So in the 1950s, we had the mainframes and the time sharing systems. So early mainframes and time sharing systems allowed multiple users to share a single physical machine. So this concept laid the foundation for resource sharing and efficiency. So this already we saw like how multiple persons were allocated to a single physical machine, and each person had a dedicated slot to use that machine. So this we already discussed in the introduction of cloud computing as well. So in the 1970s, we had this virtualization on IBM systems. So IBM is a enterprise multinational company based in the US. So their full form is International Business Machines. So what they did is they introduced virtual technologies on its mainframe systems with the release of the IBM System 370. So this included capabilities such as virtual machine and the use of hypervisors. Actually, what virtualization on IBM systems in the 1970s, it was a very pioneering development that laid the foundation for modern virtualization technologies. So IBM actually played a significant role in the evolution of virtualization. So they introduced concepts that are still influential today as well. So the key technology that emerged during this era was the IBM's system slash 370 architecture and the accompanying virtual machine facility slash 370. So this system slash 370 architecture, it was introduced in the early 70s. So it was a family of mainframe computers developed by IBM. So it featured a set of instructions and hardware specifications that form the basis for IBM's mainframe systems what we have today. So the system slash 370 architecture was designed to be very versatile and scalable, hence providing a foundation for various computing needs. So at the core of VM slash 370 architecture, there is a hypervisor. So they often refer to it as the control program. So what that hypervisor did was it facilitated the creation and management of virtual machines, serving as an intermediary between the hardware and the various operating systems running in the virtualized environments. So the hypervisor provided isolation between virtual machines, allowing them to operate independently. So it also introduced the concept of time sharing as well. So time sharing allowed users to share the computing resources efficiently. So actually this had a very lasting impact on the field of virtualization. So concepts such as hypervisors, virtual machines and time sharing, which were pioneered during that era, continued to be fundamental to modern virtualization technologies. So jumping into the 1990s, we have the 86 virtualization. So VMware, which was founded in 1998, it played a very pivotal role in bringing virtualization to this x86 architecture. So in 2001, VMware released VMware ESX, a hypervisor based virtualization solution that allowed multiple virtual machines to run on a single physical server. So coming to the x86 virtualization, so VMware actually it is also a US based product company. It was founded in 1998 by Dan Green, uh, Mendel Rosenblum, Scott Devin, and some other people actually. So its initial focus was on developing virtualization solutions for x86 based systems. In 2001, actually, they introduced this GSX server, which was later known as the VMware server. So that marked a very significant breakthrough. So GSX server was a type 2 hypervisor, so that ran on top of an existing operating system, allowing users to create and manage multiple virtual machines. So this product actually found widespread adoption in test and development environments, and also it provided a very cost-effective way also. So currently they have this vSphere solutions. So around the late 2000s and beyond. So they continue to enhance the virtualization platform with the introduction of vSphere. So it is an integrated suite that expanded the capabilities of the infrastructure that we currently use today in terms of hybrid cloud environments. So actually the 90s and early 2000s, this VMware also laid the groundwork in the virtualization technology. Also in the early 2000s also we had this hypervisor technologies. We had other companies such as Microsoft with Hyper-V and Sensors with Xen, which introduced their own hypervisor technologies. So contributing to the proliferation of x86 virtualization, which is already done by the VMware company. So around the mid 2000s, like 2005, 2006, we had the boom of this cloud computing revolution. So the term cloud computing it gained popularity as the internet based services evolved. So AWS launched in 2006. So it offered IaaS, which is an infrastructure as a service, with services like Amazon EC2, which is a compute based offering. And again in the late 2000s, we had this PaaS, which is platform as a service and software as a service. As the cloud matured, so we got these offerings. So cloud computing expanded to include platform as a service offerings such as Google App Engine. So App Engine is a PaaS, so you just need to run your code there, and you can like utilize the existing machines in the backend. You need not manage the virtual machines. You just run your code, and in the backend it is maintained by the Google. And also we have this Microsoft Azure App Services, which is a similar solution. So SaaS solutions also came up like Salesforce, which is at the forefront of CRM tools we have today. And later these services gained prominence. So these were the couple of history related aspects. After the 2010s, we had this hybrid clouds and containerization. So hybrid cloud architectures combining on-premise infrastructure with public and private clouds became prevalent. So containerization technologies such as Docker gained popularity for application deployment and portability. So you may be wondering what this hybrid cloud is. So in a hybrid cloud, what happens is the public cloud component, which involves utilizing computing resources and services from third-party service providers as AWS, Microsoft Azure, or Cloud Platform. So these services are accessed over the internet, and organizations pay for resources on a pay-as-you-go or subscription basis. So public clouds offer scalability, cost effectiveness, and a vast array of services, making them suitable for variable workloads and specific use cases. So it also involves the private cloud aspect as well. So private cloud means your own on-premise setup, which is having your own data center. So this involves a dedicated and isolated cloud infrastructure that is owned and operated by the organization itself. So we are not going to the public cloud providers in some aspects. So the concerned company is hosting its own cloud infrastructure. So private clouds can be hosted on premises in the organization's data centers or provided by a third party vendor. So private clouds offer greater control over security, compliance and customization, making them suitable for sensitive data regulatory requirements and applications with specific performance needs. So what hybrid cloud allows is it helps organizations to balance considerations as well by utilizing cost effective public cloud resources for certain workloads and maintaining control over infrastructure costs in the private cloud. So we also had the availability of Docker also here in the same phase of 2010. So it helped the problem of it doesn't work on my machine. So usually what happened, there used to be more clashes between the developers and the testers where they when they were testing the application. So when Docker arrived, it ignored like whatever the platform of testing is involved. So Docker, we can test the application in any environment. So we can containerize the app and we can test it for production. And in the 2013 we had the OpenStack and cloud standards. So the OpenStack project was launched. So it provided open source software for building private and public clouds. So there were some standardization efforts including initiatives by organizations like the CNCF, which is Cloud Native Computing Foundation, which is aimed to establish common practices for cloud native technologies. So what I would suggest is go go through the CNCF website. So you can go to the Google browser and type CNCF. You can see that there is a open source organization which is advocating for the free and fair use of all the software suites that are available in the cloud world today. So they don't advocate the business aspect like licensing and all. They always promote open source efforts. And in 2015 we had the concept of serverless computing. So serverless is just a buzzword, like where you are not managing the server, that's it, but in the backend it is running on a server which is managed by a cloud company. So in 2015 we had the onset of the concept of serverless computing, so where developers could focus on writing code without managing the underlying infrastructure. So we had the AWS Lambda and similar services. We had the Google Cloud Functions and we had the Azure Logic apps also from other cloud providers, which popularized this serverless approach. Uh, in the present multi-cloud and edge computing space, currently what the world is moving towards is multi-cloud strategies where like companies are using more than one cloud provider because they don't want to go through the vendor lock-in process. So if something happens to one cloud, they can move their workloads to another cloud. So leveraging services from multiple cloud providers gain traction for increased flexibility and redundancy. Edge computing, bringing computing resources closer to the end users or devices, became an important trend for latency sensitive applications. So mostly these social media applications that we see like Facebook and WhatsApp or any other media related applications where like we need the up to date information readily available. So for streaming applications like Hotstar we have from Disney, so they leverage this edge computing. So if people from India they want to watch a live match, so they can stream from the India location as well. So they all the infrastructure needs to be in India to facilitate that. So these are all the modern happenings in terms of virtualization. So coming to the first question, what is AWS EC2? So EC2 is a full form for short form for the Elastic Compute Cloud. So there is a single E and there are two C's. So the word is EC2. So Amazon Elastic Compute Cloud, Amazon EC2 is a core web service provided by Amazon Web Services that enables users to rent virtual servers known as instances in the cloud. So EC2 instances serve as scalable and resizable computing resources that allow users to run applications, host websites, and handle various computing workloads without the need to invest in and maintain a physical hardware. So what we need to know from here is, so Amazon Elastic Compute Cloud, it is a very fundamental web service provided by Amazon Web Services. So what the word that is uh, focus for us here is an instance. So in the context of EC2, you can say an instance refers to a virtual server in the cloud. So users can choose from a variety of pre-configured instances with different compute, memory and storage capacities. For example, if you have a website that experiences varying levels of traffic, you can use EC2 instances to scale up during peak periods and scale down during quieter times to optimize costs. So actually these cater to a broad range of use cases. For instance, if you are a startup developing a new application, so you can use EC2 instances for hosting your application servers. So if you are an enterprise dealing with varying workloads, you might also employ EC2 for batch processing, data analytics, or running mission critical applications. So this is just a virtual machine service which is provided by AWS, you can say. So this is from the Amazon official documentation. It says Amazon Elastic Compute Cloud offers the broadest and deepest compute platform with over 750 instances and choice of the latest processor, storage, networking, operating system, and purchase model to help you best match the needs of your workload. So we are the first major cloud provider that supports Intel, AMD, and ARM processors. The only cloud with on-demand EC2 Mac instances, and the only cloud with 400 GB per second Ethernet networking. So we offer the best price performance for machine learning training as well as the lowest cost per interference instances in the cloud. So more SAP high performance computing ML and workload Windows workloads run on AWS than any other cloud. So this is a very big flex that AWS is making here. So obviously they are the first cloud providers that came into existence, and they have grown enormously ever since. So there are numbers in front of you here itself. So it exaggerates that it's the broadest and deepest computer. So broadest in the sense they have a wide variety of categories and compute offerings spanning like compute optimized. We have this general optimized. We have this memory optimized. So there are a couple of categories that we'll see later. So they have a very wide category of uh, virtual machine offerings, and they also have a very deep configurations. Like they are uh, very much customizing at the CPU level, at the RAM level, at the storage level, at the processor level, you can say. So they have very deep configuration and customization platform. So with over 750 instances means server, we have around 750 different types of configurations, and we also have the choice of the latest processor. So they are always updating with the latest launches by the company. So they are always updating a new processor, a new RAM type, a new generation of storage, you can say, and the latest networkings and the latest OS. So they are always patching the new OS as well. So and the purchase model. So there are new purchase models always. You can customize like what kind of timelines you want and what sort of duration you want. And they also claim that they are the first major cloud provider that supports Intel, AMD, and ARM processors. So these are three market leading manufacturers of chipsets. So you may have heard of Intel, AMD. AMD actually manufactures Ryzen. So you may have in Flipkart or Amazon heard of Ryzen processors. So Intel similarly manufactures i5, i7 kind of processors. So ARM is also a good manufacturer. So it says that it's the only cloud with on-demand EC2 Mac instances. So even Mac is also available, and it also says that it's the only cloud with the 400 gigabyte per second Ethernet networking. So this is a very remarkable achievement in terms of AWS. So they also offer the best price performance for machine learning training. So if you are running the ML workloads, then you can utilize this EC2. Uh, they also claim that more SAP high performance computing ML and Windows workloads run on AWS than any other cloud. So like you can see, since they are having a market share of 32% already, so around 30% of the world's innovation that is happening, you can say, on cloud related to ML or any cutting edge technologies, you can confidently say that it's happening on AWS EC2. So this is their official statement that I have taken from the AWS. So to know that how robust the service of AWS currently have come up. So there are a couple of use cases of AWS EC2. So one is the we'll see one by one. So the first one is run cloud native and enterprise application. So cloud native means, so you may have come across this first word as cloud native. So cloud native actually it refers to a set of practices and methodologies that leverage the capabilities of cloud computing to design, build, deploy, and manage applications. So cloud native development is focused on maximizing the advantages offered by the cloud platforms such as scalability, flexibility, and resilience. So cloud native means also there are a couple of other buzzwords. You can say the microservices architecture. So currently, if you are in the latest, you are reading the blogs or something and watching videos, you see lot of microservices architecture. So cloud native applications so are often built using a microservice architecture. So what this architecture helps is, this approach involves breaking down an application into smaller independently deployable services. So each service is designed to perform a specific business function and communicates with other services through APIs. Microservices promote modularity, scalability, and ease of maintenance as well. So cloud native means also you have the concept of containerization. So containers are lightweight, portable, and consistent environments that encapsulate an application and its dependencies. So technologies like Docker have become integral to cloud native development. Containers enable developers to build, package, and deploy applications consistently across different environments. Meaning, for example, an application may be having UAT. So we have this couple of testing, under production, and staging environments. So it fosters reproducibility and reducing the dependency issues. Also, like by using EC2, what we are achieving is the DevOps practices. So since we are dealing with the cloud native technologies, it automatically emphasizes DevOps practices. So it promotes the collaboration between development and operations teams. So CI/CD and automated testing are key components of a DevOps approach. So this is pretty much about cloud native. So Amazon EC2 it also delivers secure, reliable, high performance and cost effective compute infrastructure to meet the demanding business needs. So being cloud native is very much a business need nowadays. Also the scale for HPC applications. HPC means high performance computing. So access the on-demand infrastructure and capacity you need to run HPC applications faster and cost effectively. So we can also develop for Apple platforms. So we can build, test and sign on-demand macOS workloads. So we can access environments within minutes. We can dynamically scale capacity as needed and benefit from the AWS pay-as-you-go pricing. So even macOS related applications can also be developed using the EC2. So we can train and deploy the ML applications. So Amazon EC2 delivers, since we already saw, it has the broadest choice of compute networking up to 400 GB per second and storage services purpose built to optimize price performance for ML projects. It is also very compatible to machine learning related applications. So coming to the features of AWS EC2, the first thing is the global infrastructure. So as we already saw in the AWS fundamentals, since AWS has its infrastructure globally, like literally in almost all the developed countries in the world, you can say that EC2 is a very global service, you can say. So it has availability in multiple locations. So Amazon EC2 provides the ability to place instances in multiple locations. So Amazon EC2 locations are composed of regions and availability zones. Availability zones are distinct locations that are engineered to be insulated from failures in other availability zones and provide inexpensive, low latency network connectivity to other availability zones in the same region. So by launching instances in separate availability zones, you can protect your applications from failure of a single location. Regions consist of one or more availability zones and are geographically dispersed. You mean like for example, Mumbai region is completely different from the Hyderabad region in case of India. And within Mumbai, there are around like for example availability zones, you can say, which is around 100 or 200 kilometers apart at least. So the Amazon EC2 service level agreement commitment is 99.99% availability for each Amazon EC2 region. So two nines is a pretty good availability SLA for a global service as EC2. So it says like please refer to regional products and services. So if you have more doubts, you can go to the AWS documentation and read the different features. And also the next good feature is high precision time with Amazon time sync service. So the Amazon time sync service provides a highly accurate, reliable and available time source to AWS services including EC2 instances. For instructions on how to access the service, we should see the setting the time sections of Linux and Windows user guides. So to understand the Amazon time sync service, actually Amazon Time Sync service, it is a service provided by Amazon Web Services that helps customers synchronize their computer clocks with the coordinated universal time using the network time protocol. So accurate time synchronization is crucial for various applications and systems, especially in distributed and cloud-based environments. So the key features of this time sync services, the Amazon time sync service is designed to provide accurate and reliable time information to AWS customers. So it helps ensure that clocks on their instances are synchronized with the global time standard UTC, which is essential for coordinating activities across different systems and applications. So accurate timekeeping actually is often a requirement for compliance. So various companies and other industry organizations, they adhere to these regulations and standards. So the Amazon Time Sync service assists AWS customers in meeting these requirements by providing a reliable source of time information. So you can say that EC2 instances are covered under this. We also have a wide variety of choice of operating systems and software. So Amazon machine images are pre-configured with an ever-growing list of operating systems, including Microsoft Windows and Linux distributions such as Amazon Linux 2, Ubuntu, Red Hat Enterprise Linux, CentOS, SUSE, and Debian. So the Amazon works with our partners and community to provide you with the most choice possible. The AWS Marketplace features a wide selection of commercial and free software from well-known vendors designed to run on EC2 instances. So the EC2 has all the world's most popular operating systems. So you can spin up a server based on Amazon Linux, which is the native Linux operating system of Amazon. So we also have Red Hat Linux, which is the enterprise Linux operating system. It also caters to the SUSE Linux, which is another popular provider. And we also have this Ubuntu, which is a platform provided by Canonical. And we also have this Windows related. And more options, we also have this Mac OS as well. Also, you may be hearing AMI. So, what are Amazon machine images? So, in simpler terms, Amazon machine images is like a snapshot or a template of a virtual server. So, that you can use to create identical copies of that server. So, it's a way of packaging up a virtual machine, you can say, including its operating system, applications, and configurations, so that you can easily replicate it or share it with others. So you can also think of the AMI as a blueprint for a virtual server. So for a house, before you construct a house, you take a plan, right? So imagine like you are going to a architect and getting the master plan of that building before you construct. So you already know what is going to be built in a plain sheet of paper. So similarly, it contains all the necessary information to launch a virtual machine with specific configuration. So this includes details about the operating system, software applications, security settings, and any data you might want to include. So when you create an AMI, so it's stored in the Amazon Web Services, and from there you can use it to launch new instances whenever you need them. So actually this is very handy feature for various reasons. The first one is reproduction. So reproduction means you can reproduce multiple instances that are identical to each other. So ensuring consistency across your infrastructure. So another thing is the backup and recovery. So AMIs, they serve as a backup mechanism. So if something goes wrong with an instance, you can launch a new one from the AMI quickly. So it is also a scalable feature. So when you need to handle more traffic or workload, you can easily launch additional instances from the same EMI to scale your application. So there is also sharing and collaboration. So you can share your AMIs with each other and making it easy to distribute a pre-configured environment or collaborate on projects. As a simplification, AMI, actually, Amazon Machine Images simplifies the process of deploying and managing virtual servers in the AWS cloud, you can say. So, coming to the next feature of EC2, you have the cost and capacity optimization. So, we need to pay for what use. So, since the cloud itself is built on the pay as you go pricing, you can see with per second billing, you only pay for what use. So it takes the cost of unused minutes and seconds in an hour of the bill. So you can focus on improving your applications instead of maximizing usage to the hour. So you can learn more about the EC2 pricing in the official documentation. So it's a very nice thing that instances are built on an hourly basis here with a 1 hour minimum, but instances that are running for less than a full hour are billed per second. So this provides a very granular pricing based on actual usage. Users can also leverage the AWS pricing calculator to estimate the cost associated with running EC2 instances based on their specific requirements. So another thing is scale seamlessly with the Amazon EC2 auto scaling. So Amazon EC2 auto scaling allows you to automatically scale your Amazon EC2 capacity up or down according to the conditions you define. So you can use the dynamic and predictive scaling policies within EC2 autoscaling to add or remove EC2 instances. So predictive scaling uses machine learning to proactively allocate instances based on anticipated demand, and dynamic scaling allows you to scale compute based on defined metrics. So with EC2 autoscaling, you can ensure that the number of Amazon EC2 instances you are using scales up seamlessly during demand spikes to maintain performance and scales down automatically during demand lulls to minimize cost. So for example, imagine that you have an application. So every day the peak uh, traffic for that application, like how many users that are trying to interact with the application, reaches at 12 p.m. in a day. You can imagine like that. But for the rest of the day it is like only 20% of the traffic is coming to the application. So what EC2 autoscaling feature we can leverage here is based on the demand. If there are 100 users, then there are 100 EC2 instances, and if there are only 5 users, then automatically the scaling of the servers will come down to 5 users. So here there is a win-win situation for both the company and AWS as well. So the customer is also paying less money, you can say. So the scaling is a wonderful feature here. Uh, there are some other cost optimizations, like we can optimize compute performance and cost with Amazon EC2 Fleet. So with a single API call, Amazon EC2 Fleet lets you provision compute capacity across EC2 instance types, availability zones, and purchase models to help optimize scale, performance, and cost. So you can also access EC2 Fleet capabilities via Amazon EC2 autoscaling to provision and automatically scale compute capacity across EC2 instance types, availability zones, and purchase options in a single autoscaling group. So you can see again Amazon EC2 Fleet. It is a service provided by Amazon Web Services that simplifies the process of provisioning and managing multiple EC2 instances. So the EC2 fleet allows users to create and manage a fleet of EC2 instances. Fleet means a bunch of EC2 instances. So you may have heard a fleet of cars, a fleet of cars. Usually it's a huge number. So what EC2 fleet does is it allows users to create and manage a fleet of EC2 instances with diverse instance types, sizes, and pricing options. So it makes it easier to optimize for cost, performance, and capacity as well. So like the key features of EC2 fleet are mixed instance types. So with leveraging EC2 fleet, we can allow users to specify multiple instance types within a single fleet. So one instance type, like it can be having different type of OS, you can say, like one can be a Debian one can be a Ubuntu based, one can be a Amazon Linux under a single fleet. So this is useful for applications that can benefit from a mix of instance types such as compute optimized, memory optimized, or storage optimized. So the fleet can automatically distribute the instances across the specified types. So also this EC2 fleet, what it does is it supports the use of spot instances. So we have concept of spot instances in AWS, which are like a spare EC2 capacity available at lower prices. So users can specify a portion of their fleet to be fulfilled by the spot instances, taking advantages of cost savings while maintaining flexibility. So this is actually particularly useful for fault tolerant and scalable workloads. So EC2 fleet also supports the automatic scaling based on the specified target capacity. So as demand changes, the fleet can scale up or down to meet the requirements, making it well suited for dynamic workloads. So EC2 Fleet also integrates with AWS auto scaling, so allowing users to combine the benefits of EC2 Fleet with the ability to scale EC2 instances based on predefined policies, you can say. So this is about the performance and cost with AWS EC2 Fleet. Coming to the optimized CPU configurations, so the optimized CPUs feature gives you greater control of your Amazon EC2 instances on two fronts. First, you can specify a custom number of virtual CPUs, vCPUs in short. So when launching new instances to save on vCPU based licensing costs. Second, you can disable Intel hyper-threading technology for workloads that perform well with single-threaded CPUs, such as certain high-perform computing applications. So it can also be EC2 can also be leveraged for the optimization of the CPU configurations, you can say. So we also have the facility of pause and resume your instances. So you can hibernate your Amazon EC2 instances backed by the Amazon EBS, which is the elastic block storage, which is a storage type for Amazon. So we'll see what EBS is in the future separate session on that, and resume them from this state at a later time. So applications that take a while to bootstrap and persist state into memory can benefit from this feature. So hibernate means to go in a stop condition for a longer time. So we also have the flexibility to stop and resume the instances operation. So the next one is storage. So EC2 can handle the optimal storage for every workload. So different Amazon EC2 workloads can have vastly different storage requirements. So Amazon Cloud Storage is reliable, scalable, and secure storage for data. So Amazon EBS, Elastic Block Store, Amazon EBS in short, is an easy to use high performance block storage. So Amazon S3 also we saw previously, it is a object storage with industry leading scalability, availability and security. So for file storage we have the Amazon offers a complete portfolio including the EFS, Amazon EFS, which is an elastic file store, which provides simple, scalable, persistent, fully managed cloud file storage for shared access. So Amazon FSx file storage offerings deliver fully managed, cost-effective file storage with the capabilities and performance of popular commercial and open source file systems. So you can see EC2 actually gels well with all the popular storage providers within the AWS environment. We'll see in deep what this EBS and EFS are in the separate session on those. And S3 are already aware, so S3 is already actually it's a very good storage solution for EC2 as well. Coming to the networking aspect, so it supports high packet per second performance and low latency with enhanced networking. So it says enhanced networking enables you to get significantly higher packet per second performance, lower network jitter and lower latencies. This feature uses a network virtualization stack that provides higher input output performance and lower CPU utilization compared to traditional implementations. So in simpler terms we can understand that higher packet per second performance in networking for EC2 means the system is capable of processing more individual units of data or packets in a given amount of time. So imagine this scenario, like you are sending letters through the email. So each letter you can imagine is like a packet of information. So the more letters means more packets you can send and receive per second, the faster and more efficient your communication becomes. So in the context of Amazon EC2, higher PPS performance in networking is beneficial for applications and workloads that involve a lot of small frequent exchanges of data. So it's making communication between different parts of a system or application more responsive and efficient. So this improved PPS performance is crucial for scenarios like real-time communication, online gaming, financial transactions, or any application where low latency and rapid data exchange are essential. So it ensures that the virtual servers or EC2 instances can handle a high rate of small data transfers effectively, contributing to a more smoother and more responsive user experience. And coming about other points, so it also can run high levels of the inter-node communications with elastic fabric adapter. So the elastic fabric adapter EFA is a network interface for Amazon EC2 instances that enables customers to run applications requiring high levels of inter-instance communications like machine learning, computational fluid dynamics, weather modeling, and reservoir simulation at scale on AWS. So EF is available as an optional EC2 networking feature that you can enable on any supported EC2 instance at no additional cost. So this is actually supporting for advanced workloads, you can say, and they say that it's actually supporting only supported EC2 instance. So before enabling this, you should see that whether that instance type is supported or not. So another thing is manage dynamic cloud computing services with elastic IP address. So elastic IP addresses are static IP addresses designed for dynamic cloud computing. So an elastic IP address is associated with your account, not with a particular instance, and you control that address until you choose to explicitly release it. Unlike traditional static IP addresses, however, elastic IP addresses allow you to mask instance or availability zone failures by programmatically remapping your public IP addresses to any instance in your account. So elastic IP is a nice IP where you can reserve a IP address. So like anyone in the world cannot use it once you reserve that elastic IP address. So EC2 also has support for this advanced dynamic cloud computing services, you can say. We'll see about elastic IP in the networking sessions. So high throughput and low latency with high performance computing clusters. So customers with complex computational workloads such as tightly coupled parallel processes or with applications sensitive to network performance can achieve the same high compute and network performance provided by custom built infrastructure while benefiting from the elasticity, flexibility, and cost advantages of Amazon EC2. So cluster compute, cluster GPU, and high memory cluster instances have been specifically engineered to provide high performance network capability and can be programmatically launched into clusters, allowing applications to get the low latency network performance required for tightly coupled node to node communication. So cluster instances also provide significantly increased throughput, making them well suited for customer applications that need to perform network intensive operations. So high throughput means high performance and low latency. So EC2 has the facility to accommodate this high performing computing clusters as well. So we can access services hosted on AWS easily and securely with AWS Private Link. So EC2 also supports the AWS Private Link, which is a purpose-built technology designed for customers to access Amazon services in a highly performant and highly available manner while keeping all the network traffic within the AWS network. So EC2 also supports this AWS Private Link. So coming to the maintenance of the AWS instances. So actually AWS, what they do in the backend is they regularly perform the routine hardware, software, power, and network maintenance with minimal disruption across all EC2 instance types. So like in the data centers, there will be people and data center technicians that would be taking care of all the hardware, software, power, and other network related requirements. So with minimal disruption. So there will be minor around a minute or two disruptions, and you will be notified in advance if that region or availability zone is under maintenance. So this is achieved by a combination of technologies and methods across the entire AWS global infrastructure, such as live update and live migration, as well as redundant and concurrently maintainable systems. So non-intrusive maintenance technologies such as live update and live migration do not require instances to be stopped or rebooted. So customers are not required to take any action prior to, during or after the live migration or live update. So if AWS has this capacity that if we are operating some EC2 machines in the backend, they are already maintaining that machine, you can say. So you need not stop or you not suspend your operations. So AWS will be handling that any related issues in the backend, you can say. So AWS uses a live update to deploy software to servers quickly with minimal impact to customer instances. And so there is a single click to deploy solution in the backend that will help uh, ease the operations of customers. So live updates ensures that customers workloads run on servers with software that is up to date with security patches. So new instance features and performance improvements as well. So comparing this to updates, for example, if a software update comes to our smartphone or a laptop, you can say. So after the update is complete, you need to switch on and restart the you need to switch off the phone or the laptop respectively to use the latest update, but not in the in case of AWS it has a feature of the live update. So while using the devices itself, the update is actually transferred. Also, Amazon EC2 uses live migration when running instances need to be moved from one server to another for hardware maintenance or to optimize placement of instances or to dynamically manage CPU resources. So Amazon EC2 has been expanding the scope and coverage of non-intrusive maintenance. Non-intrusive means there is no disruption or human related activities which needs to be required for maintenance over the years, so that scheduled maintenance events are a fallback option rather than the primary means of enabling routine maintenance. So they are using minimal downtime in their operations as well, which is a very good thing. So coming to the Amazon EC2 pricing. So Amazon EC2 is very free to try. So there are multiple ways to pay for EC2 instances. There are on demand, there are savings plan, there are reserved instances, and there is Amazon EC2 spot instances. But since we are using the Amazon free trial with our account, as part of the AWS free tier, you can get started with EC2 for free. So EC2 is one of the services that you can operate for free. So this includes 750 hours of Linux and Windows T2.micro instances. So in total you get around 750 hours of using the machine. So we'll see how that goes in the AWS console. So in the bracket they say T3.micro for the regions in which T2.micro is available. So T2 micro is a configuration of the server, you can say. But it says 750 hours each month for 1 year. So 1 year you are able to access the services in the AWS free tier, and in a month you can use it for up to 750 hours. So 750 hours, for example, if you divide it by 30 days for an average month, you can see that it comes up to almost, I think it comes to around 25 hours, you can say. So 25 hours per day. So you can spin up, I think, virtually the whole day. uh, you can say like you can use the machine the whole day for 750 hours in a month it comes. So to stay within the free tier, use only EC2 micro instances is the suggestion. So always we'll also spin up the EC2 micro instances when you do the hands-on session. So there are different types of purchase models. So purchase models in the sense there are a couple of pricing strategies devised by the AWS. So the first thing is on demand. On demand instances let you pay for compute capacity by the hour or second with no long term commitments. This frees you from the costs and complexities of planning, purchasing, and maintaining hardware and transforms what are commonly large fixed costs into much smaller variable costs. So here there is no upfront, like you need not subscribe. So as per the on demand, you means whenever you need it you can use the compute capacity. So here you are not locked in for longer subscription period. So as per AWS, on demand instances are recommended for users that prefer the low cost and flexibility of EC2 without any upfront payment or long term commitment. So if the customer doesn't want to pay a huge hefty amount upfront, for example, due to their cost constraints, or they don't want to fix for a long term commitment, so the customer don't want to use the EC2 service for around 6 months or 1 year, you can say that they can prefer for the on demand instances. So it's also suitable for applications with short-term spiky on unpredictable workloads that cannot be interrupted. So if you have an application which is a small application that need not have users, for example Flipkart, we have the big billion days, right? There we can leverage on-demand instances where like there's a very huge spike in demand for a very short amount of time. For example, the sale in the Flipkart application will be for around 7 or 8 days. So in only 8 days we need the workloads to be high. So for that time you can the enterprise can actually use the EC2 workloads, on demand EC2. Or the last resort is the applications being developed or tested on EC2 for the first time. So if you are building a cloud native application or POC, for example, and you need to test it, so on demand instances are a great way to start and test your workloads. And the next thing is the savings plan. So savings plan is a flexible pricing model that can help you reduce your bill by up to 72% compared to on demand prices in exchange for a commitment to a consistent amount of usage measured in dollar per hour for a 1 or 3 year term. Similar to the mobile subscription plans we have, like where monthly price is slightly higher. So if you take an annual plan, then the vendor actually they give sort of a discount. So similarly what AWS is providing here is they see a huge 72% save, you can where you can reduce your cloud bill compared to the on demand prices. So but we need to lock in for a period of 1 or 3 years. So this is the savings plan that are having. So AWS is currently offering three types of savings plan. The first one is the compute savings plan, the EC2 instance savings plans, the Amazon SageMaker savings plan. So SageMaker is a different AWS service. So the compute savings plan apply to usage across AWS EC2, AWS Lambda, and AWS Fargate. So saving plans are recommended for committed and steady state usage. So steady state usage means if you have workloads that you can predict actually. So I am using only this much of compute, this much of storage, and this much of networking for the 6 months or 1 year, where you can estimate that, then you can go ahead for the savings plan where you don't have any sudden spike or sudden dip in your application traffic. And the next one is it is for users looking to take advantage of the latest compute offerings while continuing to save money. So if the user is looking for saving money as a primary aspect, then you can use the saving plan. So another good thing about AWS on instance pricing policy is the availability of the easy to spot instances. So Amazon EC2 spot instances let you take advantage of unused EC2 capacity in the AWS cloud and are available at a discount of up to 90% compared to on-demand prices. It's like a gamble, you can say. So actually across the world there will be some instances which are unused from AWS, and they will put those instances in the spot instances category. So what discount they are providing, a very huge discount, so it's 90%, but these are not for the steady workloads, you can say. So these spot instances are recommended for fault tolerant or stateless workloads. So fault tolerant in the sense where you just want to use them as a secondary failover regions. For example, you already have the EC2 workloads working in one thing and you just want to have that as a backup. So you can use these spot instances for that stateless workloads. And you can also use those for applications that can run on the heterogeneous hardware. Heterogeneous means applications which are independent of the operating systems or any like hardware related issues. And spot instances are also recommended for the applications that have flexible start and end time. So you are nowhere concerned about, you don't have a steady application workload, you can say. So you are flexible with the how when the application will start and when the application will end. So spot instances are a good, what you can say, they are a good uh, I mean like they're a good package for all these relevant workloads. So the next important category that we'll dive into is the EC2 instance types. So the foremost type of the EC2 instance type is the general purpose EC2 instance type. So as per the definition, so general purpose instances provides a balance of compute, memory and networking resources and can be used for a variety of diverse workloads. So these instances are ideal for applications that use these resources in equal proportions, such as web servers and code repositories. So these are some features provided by AWS for the general purpose. They are powered by the custom built AWS Graviton 3 processors. So these are the in-house processors, just like we have the Intel i5 or the AMD Ryzen processors. So this is a custom processor built by Amazon. So it is all the general purpose instance types we have will be based on these processors. So features the latest DDR5 memory that offers 50% more bandwidth compared to DDR4. So DDR5 is a RAM type that we are having. So you may be having in smartphones also. Currently we are getting the DDR5 memory. So it's always the latest memory. So it offers 50% more bandwidth compared to the last generation DDR4. So it is also 20% higher enhanced networking bandwidth compared to M6G instances. This is the reference instance type that I have taken for the comparison purpose. So it is EBS optimized by default. So it is already incompatible with the EBS. So instance storage offered by EBS or NVMe SSDs that are physically attached to the host server. So we can have the storage that gets offered for general purposes, either IBS or NVMe SSDs. So it says with M7GD instances, these are the different types of configuration of instances. So I have a table listed, so I'll show you in the next slide. So local NVMe based SSDs are physical connected to the host server and provide block level storage that is coupled to the lifetime of the instance. So it also supports EFA on M7G.16x large, M7G metal and M7GD 16x large. So it's powered by the AWS Nitro system, a combination of dedicated hardware and lightweighted hypervisor. So hypervisor is the which enables us to host multiple VMs on the single host machine, you can say. So the use cases of the general purpose instance types is applications which are built on open source software such as application servers, microservices, gaming servers, mid-side data source and caching fleets. So it's a good combination for application servers. So this is the typical instant type. So the code word they have given is the A1, and accordingly the instance sizes we have the A1 medium, A1 dot large, A1 dot X large, A1 dot 2X large. So for one they have this one CPU and the memory of 2 GB. For A1 large we have 2 CPU and 4 GB. So in the console also how we can configure that accordingly. So the next one is the compute optimized ones. So the compute optimized instances are ideal for compute bound applications that benefit from high performance processors. So instances belonging to this category are well suited for batch processing workloads, media transcoding, high performance web servers, high performance computing, scientific modeling, dedicated game servers, and server engines, machine learning inference, and other compute intensive applications. So this is mostly for I think even blockchain also we can use this. So which since it involves very high computing prowess, we can utilize this compute optimized applications. So it can say high performance means heavy workload intensive applications we can take care of. So it is also, so coming to the features, it is also powered by the custom built AWS Graviton 3 processors, which is the in-house processor. So it also features the latest DDR5 memory, offering 50% more bandwidth. So it has the most 20% higher enhanced networking bandwidth compared to C6G instances, which were earlier like the old type of compute optimized instances from AWS. It is also EBS optimized by default. So instant storage offered via EBS or NVMe SSDs, similar to our general optimized. So with C7GD instances, local NVMe SSD based SSDs are physically connected to the host server and provide block level storage that is coupled to the lifetime of instance. So this also supports the elastic fabric adapter on C7G.16x large, C7G.metal and C7GD.16 into large instances. So it's also powered by the AWS Nitro system, a combination of dedicated hardware and lightweight supervisor. So you can see this is mostly with bit of enhancements. It is better than the general optimized ones. So the use cases are obviously high performance computing, batch processing and serving, ad serving, video encoding, gaming, scientific modeling, distributed analytics and CPU based machine learning inference. So these are the couple of configurations. The instance types are of the C type. So earlier we had the A type. So here we have the C type, C5, C5A, C5D. And these are the different instance sizes with the vCPU of 2v24. We have the C5.x large, C5A.x large, C5D.x large with a vCPU of 4 and memory of 8 GB. Similarly, we have C5N and C4. So coming to the memory optimized ones. So memory optimized instances are designed to deliver fast performance for workloads that process large datasets in memory. Actually, memory optimized instances in AWS, so they are like computers that are really good at handling a lot of information at the same time. So imagine you are working on a project and you have a lot of papers with important details. So if you had a big disk with plenty of space to spread out all those papers, you could work more efficiently, right? So memory optimized instances are like having a big desk for your computer in the cloud. So obviously there is a lots of memory. Memory means RAM. So memory optimized instances have a large amount of memory, which is like the desk space for your computer. So this is where your computer stores and quickly accesses information it needs to work on tasks. So it is good for big projects, smooth multitasking. So it's like having a super smart computer for tasks that require a great deal of memory. So the features of the memory optimized instances are: it's powered by custom built AWS Graviton 4 processors. It has larger instance sizes with up to 3x more vCPUs and memory than R7Z instances. So it features the latest DDR5 5600 memory. It is optimized for AWS EBS by default. It's also powered by the AWS Nitro system, a combination of dedicated hardware and lightweight hypervisor. So the use cases are memory intensive workloads such as open source databases, in-memory cache, and real-time big data analytics. So the instant type code here is the R family. So we have R4. So under that we have R5.large, R5 dot R5A.large, R5N.large, which has vCPU of 2 and memory of 16 GB. So you can say the memory at minimum is a 16 GB. So it goes all the way up to the 768 GB. So you can see how enormous these machines are. Similarly, we have this R4.large, which has this 15.25 GB memory. And the next family of instant types, we have the accelerated computing. So accelerated computing instances use hardware accelerators or coprocessors to perform functions such as floating point number calculations, graphics processing, or data pattern matching, so more efficiently than is possible in software running on CPUs. So actually AWS also has the use of specialized hardware, so known as accelerators, to enhance the performance of specific types of workloads. So normally these use this parallel processing power and specialized hardware for faster tasks. So you may be having this GPUs and TPUs, so which are graphic processing units and tensor processing units. So the features of this is it uses the third gen AMD EPYC processors. It has up to 8 NVIDIA H100 Tensor Core GPUs. It has up to 3200 Gbps network bandwidth with support for elastic fabric adapter and NVIDIA GPU Direct RDMA. Again, it has 900 GB per second peer-to-peer GPU communication with NVIDIA NVSwitch. So it's deployed in the Amazon EC2 Ultra clusters consisting of up to 20,000 NVIDIA H100 Tensor Core GPUs, petabit scale networking, and scalable low latency storage with Amazon FSx for Lustre. So the use cases is the currently we are hearing a lot of generative AI. So we have the Microsoft Copilot, we have the Binge Copilot, we have the OpenAI Chat GPT. So these are the Gen AI applications, including question answering, code generation. We in the Amazon also for code generation, we have the AWS Code Whisperer tool, which helps developers write the code effectively. We also have the video and image generation techniques. We have the speech recognition and more. So HPC applications also can be used at scale in pharmaceutical discovery, seismic analysis for earthquake detection, weather forecasting, and financial modeling. So we have the instance types as the G4. So the code is involved in G4DN.xlarge. We have GPU1, vCPU as 4. We have the 16 GB memory and the 16 GB GPU. So the G3 and G4 instance types normally come under the accelerated computing types. And next one we have the storage optimized. So storage optimized instances are designed for workloads that require high sequential read and write access to very large data sets on local storage. These are optimized to deliver tens of thousands of low latency random IO operations per second IOPS to applications. So the features are, it is powered by the AWS Graviton 2 processors. It is also featuring up to 15 TB of NVMe SSD instant storage with AWS Nitro SSDs that provide up to 60% lower IO latency and up to 75% reduced latency variability compared to i3 and i3 instances, and feature always on encryption. So it is optimized for workloads that map to 8 GB of memory per vCPU. It also supports up to 32 Gbps of network bandwidth using elastic network adapter. So it supports EFA on i4G.16x large instances, up to 20 GB of bandwidth to Amazon ABS, built on the AWS Nitro system again. Also it supports for torn write prevention to facilitate additional performance and reduce latencies with database workloads such as MySQL and MariaDB. So the use cases for this is Amazon EC2 i4G instances are optimized for IO intensive applications and target to customers using transactional databases. So we may have heard of databases like Amazon DynamoDB, which is the native database system for AWS. We have the MySQL, we have PostgreSQL, Amazon Open Search Service, and real-time analytics such as Apache Spark. So the instance types is the I families. So we have i3.large, we have i3x large with the relevant vCPU, memory, and SSD networking performance. We also have the i3 performance family as well. So you can take a look of the different configurations that are available. So coming to the HPC optimized. So we already heard the HPC for the compute optimized workloads previously, but here the high performance computing instances are purpose built to offer the best price performance for running HPC workloads at scale on AWS. So HPC instances are ideal for applications that benefit from high performance processes such as large complex simulations and deep learning workloads. The features here available are up to 64 crores of Graviton 3E processors with 128 GB of memory. So we have this 64 core processor of the Graviton 3. We have EFAs enabled for internal network bandwidth speeds of up to 200 GB per second, delivering increased performance for network intensive applications. So it is also powered by the AWS Nitro system, combination of dedicated hardware and lightweight hypervisor. So coming to the since we already saw all the instance types, now how the instance performance is measured. So there are two questions: why we should measure instance performance. So Amazon EC2 allows you to provision a variety of instance types which provide different combinations of CPU, memory, disk, and networking. So launching new instances and running tests in parallel is easy, and AWS recommends that measuring the performance of applications to identify appropriate instance types and validate application architecture. So you need to test your application. After you build your application, you need to test them in compute optimized or general purpose or accelerated type or HPC type. So you can use a trial and error method, and where you get the appropriate performance and cost benefits, you can go ahead and use that respective instance type for your application needs. So the considerations for Amazon EC2 performance evaluation. So AWS has provided like a bit of questions where we can evaluate ourselves whether that EC2 instance type is suitable for that workload. So It says Amazon EC2 provides with a large number of options across 10 different instance types, each with one or more size options organized into distinct instance families optimized for different types of applications. So we recommend that you assess the requirements of your applications and select the appropriate instance family as a starting point for your application performance testing. So you should start evaluating the performance of your applications by identifying how your application needs compared to different instance families. So is the application compute inbound, memory bound, or like sizing your workload to identify the appropriate instances. So there is no substitute for measuring the performance of your full application, since application performance can be impacted by underlying infrastructure or by software and architectural limitations. So hope you understood a bit of theory. So now we'll directly go to the Amazon console and do the hands-on session. So I have come to the AWS login page here. So I'll just hit the credentials. So there's some bad request. Let me refresh the page. Go ahead and so we'll go ahead and type the MFA code again. So we have 801035. So this was the previous related to the IAM policies that we have. So I'll come back now and I'll just type in the search. We need to type the EC2. So here we have the first, which are the virtual servers in the cloud. So we need to go ahead and click on that. So here's a beautiful UI that you get. So we'll go one by one. So we have the dashboard here. It says the EC2 dashboard. Dashboard, you can say it's like a neatly set layout where you can have all the information. So respectively, we have the here in the right side we have the EC2 free tier, which says offers for all AWS regions. So the EC2 is existing in all the regions. So it says 0 EC2 free tier offers in use, end of month forecast, 0 offers forecasted to exceed free tier limit. And we have all the account attributes, the default VPC. VPC is like a virtual private cloud. It's like a network setup, you can say, where you will be deploying the EC2. So here we are in the Singapore region, and this is the zones, the availability zones name, the AP Southeast 1A, Southeast 1B, and Southeast 1C. We have three availability zones. We also have the ability to enable the additional zones if you are designing a fault tolerant work type. And we have the migrate server option, and we have the additional information regarding the getting started guide, documentation, all EC2 resources, etc. In the left side we have the EC2 global view. So we'll go ahead and click the EC2 global view here. So it says like it gives you the configuration settings of all the information related to EC2, like how many enabled regions that you have, how many security groups you have, how many VPC endpoints you have set up, how many instances are there in the region, how many volumes are attached to the instances, how many NAT gateways, elastic APIs. So these all we'll discuss in the networking related aspects. So I'll again go to the, I'll just minimize the global view. It will take some time since it will process the data. So yeah, we have all the data ready now. So we have this security group 17 in 17 regions. We have VPCs. Like there will be one default VPC in every region, which is already created by AWS. So there are 55 subnets, 17 route tables, internet gateways. So these are the networking related aspects. So we'll again go to the IAM here. So I'll just click it. So I'll just type EC2 again. And here we are back to the dashboard again. So under the resources we can say it will show the instances running. Instance means the VM, we can say. And there are no, since I haven't spin up any virtual machine until now, so the count is 0. We also have in the left we have the instances. So we'll click on instances. So currently it's blank, so there is no instance. There are instance types. So the loading, so you can see there are a variety of instance types available. So I'll just maximize. So starting with the T1.micro, which is a V1 CPU and a zero point 0.6 GB memory. So the network performance is very low. So the on-demand Linux pricing is 0.02 USD per hour, and the on-demand Windows pricing is, Windows means these are the OS related pricings. It is the 0.02 USD per hour. We also have launch templates. So launch templates, we can use launch templates to automate instance launches. We can simplify permission policies and enforce best practices across your organization. So launch template means just you can design a template to launch an EC2 instance, and you can create that for the rest of the EC2 instances. There are some spot requests as well. So we have the savings plan if you are going for long-term commitments. So spot requests are for ad hoc spot requests, like you can request spot instances if you don't, for testing purposes. So these are for fault tolerant workloads. You should not use them as the primary instances, but as discussed, these should be for fault tolerant operations. We have the reserved instances. So they have the recommendation that we recommend savings plan or reserved instances. So savings plans are the easiest and most flexible way to save money on your AWS compute costs and offer lower prices up to 70% off, just like reserved instances. So we have dedicated hosts, we have capacity reservations, so AMIs. So AMIs are already pre-built, like you can also customize, or you can use the EC2 image builder to actually build an image from start. So based on the image you can go ahead and start building the EC2. So we'll try to create first EC2 instance. So in this hands-on session on, we'll try to create our first EC2 instance here. So the first thing we have to do is we have to select the region here. So by default it would be North Virginia, which is the US East 1 region. So we'll click on launch instances. So once you hit the launch instance, you can see there are a number of steps. So we'll see one by one in deep. So it has the first launch and instance option. So Amazon EC2 allows you to create virtual machines or instances that run on the AWS cloud. So quickly get started following the simple steps below. So we'll go on adding one by one the details required. So the first step involved here is the name and tags. So we have to give the name of the virtual machine or the server that we are spinning up. The second step is the application and the OS image, which is AMI in short, which is also called as the Amazon machine image. These are like templates, we can say. Third one is the instance type, the type of the instance that we are going to spin up. The fourth is the key pair. So if you want to log in into the instance or securely, you need to have a key pair. And these are all the network settings, you can say. And the next one is the storage options that we need to attach. So here we'll give our first name as the test internship studio. We can also add additional text. So it's always a good practice to add the tag. So I'll just sorry, it's I think the name is already created. So we can add new tag. So we can have the created by and I can say internship studio. And yeah, this must be enough. And here we will select the application and OS image, so the platform based on which this instance is gonna build upon. So there are like couple of options. Though the first one is the Amazon Linux, which is their in-house built Linux based distribution. We have the Mac OS, we have the Ubuntu, we have the Microsoft Windows, we have the Red Hat, we have the SUSE Linux. So if you click this drag option button, we also get to know SUSE Linux, and you can use browse more EMIs as well. So you can see there are 47 which are at present visible. So we have this Amazon Linux, macOS Sonoma, macOS Ventura, macOS Mentore, and lot of things like we have this Ubuntu, we have Microsoft Windows, so we have Debian. So for our simplicity, we'll go back now. So we'll go to the launch and EC2 instance. So already given the name. So it says in the box Amazon Linux 2023 EMI. So it's free tier eligible. So always ensure, since we are using the free tier account, the instance that we are using is free tier eligible. Otherwise you would be charged on your card and unnecessary costs would add up. So let me select the default Amazon Linux here. Uh, one more time I am reminding, just be sure that you get this box, the AMI should be free tier eligible, so to avoid unnecessary costs and billings to your AWS account. So the instance type is the actual configuration of the machine that we are going to spin up. So the family is T2, the name is the T2.micro. So instance type is also free tier eligible. So it's just a 1 V CPU and a 1 GB memory, and the current generation is set to true. So these are the different on-demand Windows based pricing. So this is Windows based, means the OS is Windows. Here SUSE means the OS is SUSE Linux. So RHEL Red Hat Enterprise Linux, and this is the normal Linux based. So we have different pricings for, we have this 0.01 116 USD per hour. So this is the different type of pricing strategy for all this. So it also reminds that additional costs apply for EMIs with pre-installed software. So if we have an EMI like this EMI for example with any custom built software, then you would be charged extra for that. So this is about the instance type that I have selected. So we can also go ahead and select like there is T2 Nano, which is smaller than the micro as well. So we have T2 small, we have T2 medium, we have T2 large, T2 extra large, T2 2XL, T3 nano. There are like hundreds of combinations if you can scroll through again. But what we require is the free tier eligible. So please be sure that you always select the free tier eligible for unnecessary avoidance of billing. So next one is the key pair login. So the next step is the creating a key pair. So you can use that key pair to securely connect your instance. So since I don't have any key pair already, but actually it's not recommended to proceed without a key pair. So I'll just create a new key pair. So I'll just instance login. It will ask to give the name of the key pair. So I'll just type instance login. So you can use the .pem file only, and we have this another option format of .ppk. So just go with the rsset key pair type and with the .pem file. I'll hit on create key pair. So it's already there. Okay. So it's I have selected the instance, so it is already downloaded in my downloads here. You can check in your own machine as well. So the next important part is the network settings. So network is everything is cloud is based on the network. So VPC is short form for the virtual private cloud. So you have to set because you are spinning up server and you have to be sure where you are putting that server in. So in which network aspect you are like placing that server in. So is it a dev VPC? For example, if you are having an application server, then you need to specify whether it is a prod VPC, dev VPC or a test VPC. So in that case, VPC plays an important role. So for now, since we aren't dive into the VPC, so we'll just go ahead and select the default VPC here, which is already available once you create the account. So we have this info. Subnet is full form for the subnetwork. So no preference. So default subnet in availability zone, in any availability zone. So we also enable the auto assign public IP. So actually, since we are using the default network settings, so VPC and subnet is taken care of. So we are using the default ones. So auto assign public IP. So the server that we spin up. So since auto assign public IP is enabled, so it will come up with the public IP address. So the next important part is the security groups. So it's like a firewall. Firewall means it's like to keep a guard of what and who is allowed to enter our server. So a security group is a set of firewall rules that control the traffic for your instance. So which people are who can access the server. So which IP addresses or who can do what, like who can do SSH or other kind of traffic from the outside world. So that will dictate the security group rules. So we'll discuss security groups and firewalls and all these network related aspects in our network related sessions. For now, just understand that it's like a guard dog, you can say, like who we and what or which kind of traffic will come into our server. Now we'll go ahead and create a security group. So it will create, what it will do is it will create a new security group called launch wizard -1 with the following rules. So it says allow SSH traffic from like In the box we have anywhere, right? But please be reminded that rules with source of 0.0.0/0 allow all IP addresses to access your instance. So we recommend setting security groups to allow access from known IP address only. So for safety condition, we are not allowing to the whole world. We'll just restrict it to my IP, which is my own IP address. So what I'll do is I'll just allow this HTTPS traffic also, and I'll allow this HTTP traffic from the internet. So the next important point is the configuration of storage. So I will use 8 GB like GP3 root volume, and it says that we have an info note saying free tier eligible customers get up to 30 GB of EBS general purpose SSD or magnetic storage. So I think, yeah, we are pretty much done. We can ignore the advanced details for now. I think there are some kind of domain join directory M instance profile, a lot of unnecessary stuff. Oh, if we need to fine grain the EC2 instance, for now it's enough. So we'll just go from the starting. So the name and tags are taken care of. So we already selected the Amazon Linux here. We have the T2 micro. I have already created a new key pair login. So the security group is created. So I have restricted the allow SSH traffic to my IP itself only for security reasons. And now I'll go ahead. In the right side we have this as it has a 8 GB memory, so one volume, and I'll go ahead and launch instance. So it says creating security groups, launching initiation. So we have successfully created. So it says success. So successfully initiated launch of the instance. You mean our server is ready now. So we'll just go to the instances section here. It says running. So in the status instance state we have this running. So this is the name of the instance that we have. So you can also extend the bars here. So this is the instance ID. So it is the instance state. It is the instance type, that is t2.micro. The status check is initializing. So we have alarm status, we have availability zone. Since we have deployed this instance in the North Virginia region, which is US East 1, so the availability zone that is there is the A. So we have three availability zones, A, B, C. So it is deployed in the availability zone 1A. So this is the public IP address. So we don't have any elastic IP or IPv6. So monitoring is disabled. The security group name is the launch wizard 1. So the key name is the instance login. So the launch time is the GMT plus 5.30, and the platform is the Linux or Unix one. So what we'll do is, since our instance is already running, so we'll try to connect to that instance from a local terminal. So what we'll do is just inside the details that we have here, so we'll take the public IP address here, and what I'll do is I'll just quickly go into my terminal in the local machine. So we have this Windows terminal. So I'll just do an SSH hyphen I. So let me just check the downloads. What is the name of, just change the directory here to downloads. Less. So we have the instance login.pem has the file name here. So we will just ssh -i instance login.pem, which is the file name. So we'll do ec2 user at the rate, we'll copy paste the IP address here. So let me try to hit enter. So it asks as a prompt, are you sure you want to continue connecting? So let's say yes, permanently added. So congratulations, you have successfully connected to the Amazon server from our local terminal. So we can also cross verify the IP whether it is the same. So we have 172.31.34.177. So we'll go ahead and check. So it is the same. It's the 172.31.34.177. So the IP address is matching to our terminal, like what we have accessed from here. So let me just. Also, there is one more type of connecting the EC2 instance. So this is via the SSH key pair that we have, but uh, let me show you some other types of connecting, how to connect to the EC2 instance. So let me go into the instance. So we have, under this instance we have the description, right? So we have the connect option here. So one more good thing is we can directly connect via from the console as well. So connect using EC2 connect. So we can connect using the EC2 connect instance, connect browser based clients with a public IP v4 address. So the username is EC2 user and this is the public IP address. So I'll just hit the connect option here and it will redirect to a browser here. And this was pretty much simple. Like in the backend it is establishing connection with the server. Since we have actually allowed only my IP to be connected, so this is a bit of a failure here, but we'll ignore this for now and we'll try to connect. Let's see if we can connect via the instance connect endpoint. But we need to create an endpoint first. We'll just create the endpoint here. So I'll just hit this as my endpoint. We have this, select that it has a EC2 instance connect endpoint. We'll select the VPC, which is the default VPC. We'll select the security group ID. We'll select the subnet. So subnet can be a default one, which is to create. Let me select a random one. So let me hit created by, no, let it remain the same, the tag. So we'll create the endpoint here. So the endpoint is already created, so we'll just go ahead to our EC2 again and we'll just hit the refresh button here so that that endpoint should get populated. So let me use this. So we'll select an endpoint. So it takes around couple of 3 or 4 minutes to for the endpoint to get created. So let's wait for some 2 or 3 minutes. So these are meanwhile I'll show you this is another thing. So session manager, we can enable this also. We can use the SSH client as well. So you see this is the EC2 serial console, but for now our account is not authorized to use the EC2 serial console. So let me check if it has come up. It's still in progress. So under monitoring we can see the CPU utilization, the network packets, the network in bytes, the out bytes, the disk writes, and various other parameters for advanced monitoring. This is the time intervals. This is for the past 1 hour. This is the 3 hours. So there are some regular intervals. You can also have the time zone. And under security, we have the security groups related things. We have the inbound roles. Since we are allowed HTTP and HTTPS both and the TCP, so we have this respective inbound rules here. So let me again. So here we have the instance state. We can stop the instance. We can reboot the instance. Terminate means we can delete the instance here. So there are also a couple of actions. We have instance settings. We have networking related, security related, and other things. So let me go into the instance again. So let me select the instance and try to hit connect. I think so. So it's still the creation is in progress. Let me refresh again. So you can also see the status here. So let me refresh the endpoint status. So it's still in pending state. Uh, Actually it takes around 5 minutes or so, 4 to 5 minutes. So please be patient. Like if you are already while creating, so don't be like it's not related to some bandwidth or AWS related things. It is in the backend. AWS takes this amount of time to create that endpoint for us. Just keep hitting refresh. So you can finally see like after around 4 or 5 minutes it says the status as available. So let's now freshly again I'll refresh this. So we'll again connect using EC2 instance connect endpoint, and I'll use the uh, created endpoint now. So we'll hit create. So why this actually it is failing is we have uh, shortlisted that IP like my own IP. So we'll again re-edit that security group of ours, and we'll check once again to allow any IP to get listed. So I'll just go ahead in the IP in the security. This is the launch wizard one, which is our security group. So I'll edit the inbound rules again. So let me remove this and do it to anywhere IPv4. So I'll click and save the rules. So again, I'll try to connect it once again. So under the endpoint says available again. Let me try to once again go into the EC2 instance, connect. So use this. Yeah, now you can see that we're able to access the instance from the browser itself. So since I had whitelisted my IP due to security reasons, so we are not able to do that. So currently, since it's accessible from anywhere across the world, so you can access this instance. So there is also, other than the private endpoint, also we have another type of way to connect. So we'll just hit the connect here. So we used earlier the EC2 instance connect endpoint. Now we'll just use the EC2 instance connect. So we'll just hit the connect from here. So yeah, again here also we are able to access the internet. So I'll just do an ls. ls is to list all the items that are available in a directory, you can say. So it says Amazon Linux S 2023, and this is the IP address. So we have currently seen three ways of accessing the instance in the AWS console and via our local terminal. So this was pretty much about our EC2 instance creation. So I'll just in under actions I'll just go ahead and delete. I'll just instance settings. I'll just go ahead and terminate the instance. Okay, I'll go ahead and terminate. So it first shuts down before terminating. So we can see that finally the instance is terminated. So this was all about our EC2 instance creation and the different types of connecting to the instance. So we'll move ahead. So we had pretty much a good hands-on session on EC2. So coming to the conclusion part, so I'll list out some EC2 best practices that you have to follow. So the first one is the right size instances. So choose the right instance type based on your workload requirements. So always consider factors such as CPU, memory, storage and network performance. AWS offers a variety of instance types optimized for different use cases. So always utilize AWS auto scaling. So implement auto scaling to automatically adjust the number of EC2 instances based on demand. So this will help you ensure that you have the right capacity at all times, optimizing cost and maintaining application availability. So also implement reserved instances. So you should utilize reserved instances for predictable workloads with a steady state usage. RIs offer significant cost savings compared to on-demand instances, especially for longer term commitments. So you should also leverage spot instances. So consider using spot instances for fault tolerant and flexible workloads as they can provide substantial cost savings. So spot instances allow you to bid for unused EC2 capacity. So also use Amazon machine images wisely. So Amazon machine images are pre-baked templates the available in different distributions. So you can also create custom EMIs to capture the configuration and software setup of your particular instances. This helps in faster instance launches and ensures consistency across deployments. So also follow good naming practices. Also you can leverage the tags as well, because tags are very important if you are working in enterprise environments. So tags should be based on what is the environment that you are creating the instance for. So these are couple of best practices that you need to keep in mind while operating with EC2. So thank you for your patient understanding of the session, and actually I suggest you to keep on going through the AWS documentation and be on top of what all different services related to EC2 the AWS releases. So in these sessions, what we got is we got an overview of what EC2 is, how the EC2 instance creation is done, what are the types of EC2 offerings that AWS provides, which are the best practices. So we also saw different ways of connecting to the EC2 instance, for example from our terminal using SSH keys, using the EC2 instance connect, and the EC2 instance connect by using a VPC endpoint. So we also saw what security groups is, and we also made sure that we only whitelisted our IP to access the EC2 instance, and also we saw the best practices. So in the next session we'll be covering the AWS EBS, which is the Elastic Block Store, and the EFS, which is the Elastic File Store. So once again, thank you for attending the session. See you in the next session. Bye.